What's the problem with it? What are you not seeing?
I got the width. The width I got my velocity, my
The
idea.
width is given to you.
I found the time for it.
What's the distance across?
0.80.
What is that, kilometers?
Oh, no, wrong one. 90 meters. 70 meters, I mean.
70 meters.
70 meters.
How fast can you swim?
It says 0.80.
No, the girl can swim at 1.4 meters.
Come on, Morgan, you gotta read the question properly. A river is 70 meters wide and it flows at 0.8 meters per second. That's not how fast she swims. A girl swims across at 1.4 meters per second. All right?
I see. She swam, I should have looked at it and thought, she swam across the river, and that's going across the river.
So now you can find the time it takes for her to get across. You just have to divide the two. 70 divided by 1.4. So put that in your calculator, please.
50.
50?
Yep.
It takes her 50 seconds to go across the river. All right?
Okay.
Follow that so far.
Yes.
Now the current is moving this way at 0.8 meters per second. So she's going to end up swimming this way, but the current's moving her this way, so she's actually going to end up over here somewhere, right?
Right.
So even though she was trying to get here, she's going to end up down here. So how far down the river is she? What do you have for information up here?
The time,
What is the time?
50 seconds.
And what else do you have?
The velocity,
So then can you find the distance?
yes.
How?
Velocity times time.
Okay, so take 50 and times it by 0.8.
40.
That's how far down the river she ends up. Okay?
Okay.
Now, if I want to find out what her speed is, like how fast she's actually swimming, you have 1.4 and you have 0.8. Use Pythagoras' theorem. So 1.4 squared plus 0.8 squared and take the square root of it. It tells you how fast she's actually swimming.
.61.
So she's actually moving at 1.61 meters per second. Follow that so far?
Yep.
So the first thing, A, what's the least time she requires to cross the river? 50 seconds. How far downstream will she be when she lands on the opposite shore? 40 meters. At what angle to the shore will she have to aim? So now this changes the question. So this is all the information that's used for this part of the question. I didn't actually need this, but I just showed you how to find it if you needed it.
Yeah.
Now, she wants to end up straight across. So, draw this again. Okay, she wants to end up over here. So she's got to swim this way. So she's swimming at 1.4 meters per second that way. Because the current is going to move her to here.
Yeah.
So that's 0.8 meters per second. She has to swim into the current in order to end up going, the current's going to move her back. So she's swimming into the current. Is she going to be swimming faster or slower?
She'll be moving the same.
She's moving the same, but if you're watching her, is she moving the same speed as 1.4? Or is she moving faster or slower?
She's moving slower
How come?
because the hypotenuse is a lower number than the other
Okay,
side.
that's mathematically speaking, that's right. Absolutely. Okay, but she's going to be swimming slower because she's swimming into the current. You're swimming against the water that's pushing you.
Oh, yeah, I see how that works now.
Okay, so now take 1.4 squared and 0.8 squared, subtract them, and take the square root of it.
1.61.
No,
I got 1.15.
1.15. 1.4 squared, subtract 0.8 squared.
Yeah, it's 1.15.
Okay? So now your distance is still 70 meters. Now how long does it take?
Divide, 70 divided by 1.15. 68.85.
87.
I think I did something stupid here.
60.87.
60?
Yeah, 60.86 or 87, yeah.
So that's the amount of time it takes. You gotta find that angle. So where is 0.8 in relation to that angle?
Opposite,
And that's called the,
hypotenuse.
so second function sine 0.8 divided by 1.4.
Uh, 37.95.
So that's the angle that's with the vertical. It wants this angle right here. Find out what that is. That's the angle relative to the shore.
One eighty,
Not 190.
oh, 190. 190, take away that number. $52.05.
There's the whole question right there, Morgan. Okay,
Okay,
so the question doesn't change. It's the same question every time. First, you gotta find out how long it takes her to go across based on how fast she swims in still water. Then you find out how far downstream she ends up. Because you got the time and you got how far the current's pushing. That's how you get your 40 meters. Following me?
Yep.
Okay? And then you have to swim, she wants to swim straight across, so she swims into the current, moves her back. That's all there is to that question. That question won't change. Okay?
okay.
What part of it's bothering you?
Well, one thing I know that I did wrong was I read the question wrong. I did it completely backwards. So, once I started, I had everything wrong, no matter what, because both sides were, yeah. And then,
Okay, so did you do the math right at least? Did you find your time by taking 70 divided by 0.8?
yes,
And then you times 50 by 1.4?
yes,
Okay, then you're off and running. Then don't worry about it. You've got what you need. Just get that right. Know which one's the current and know which one's the. Other than that, if you got all that other stuff right, then that's good. That's the hard part. Okay?
Right.
Just read the question a little bit slower.
yeah.
Okay? That's fine. You'll be okay then. Alright? Anybody else?
I had trouble getting 28, like how to set it up, and just how to get it, it's kind of backwards from what you're asking for.
Pilot maintains a heading due west. The velocity of the plane. Alright. After flying for 30 minutes, he finds himself over a town that is 150 kilometers west and 40 kilometers south of his starting point. So, what I'm going to do is I'm going to use this in order to find out what the wind speed is. Because this is what my ground speed's going to be. Right? And what do you need to know? Velocity of the wind is the velocity of the ground minus the velocity of the plane. So find your displacement. It's the first thing you find.
It's 155.24.
What's your displacement?
155.24.
What's your angle?
Going in that direction. Uh, 14.93.
Okay, so your velocity then has the same direction, but it's moving at, what's the velocity? Divide that by a half, so times it by 2.
155, so it's 310.48.
Okay, so so you have a choice. You want to use components, or do you want to just draw the two vectors together and then use law of sines and cosines?
Draw two vectors together.
Okay, so you've got to draw your velocity of your ground first. All right, so let's do this again. Velocity of the ground is equal to the velocity of the plane plus the velocity of the wind, right?
Right.
So I'm looking for the velocity of the wind. So I take the velocity, of the ground. Mix myself up here. Velocity of the ground minus the velocity of the plane. Okay, so far?
Yep.
Alright, so. What's it, 14.93
14.93.
degrees? Okay. Alright, so there's my velocity of my ground, right? I need to draw the velocity of the plane now. But it's gotta be the negative of it. It's gotta be the negative of the velocity of the plane, so what direction am I gonna draw it?
East.
East. So. And this right here is the velocity of the wind.
And just do it. I just had trouble kind of extending up that way.
So I go back to this. Because they gave us the displacements, right? I just brought in an extra step into this to find your displacement. And then in order to find your velocity of your ground speed, you just had to divide it by the amount of time.
which was half an hour.
which is a half an hour.
Okay. Yes.
Alright? And again, it comes back to this right here. That's how you draw your vectors. Use the equation to tell you how to draw your vectors.
The only thing about it is if you go to the next page. When you're solving that, how would you find an interior angle? Like that 14.93, is that a right angle with the, no?
You can put it in between the Boston and ground, like the 14.92 can go the other corner.
Oh yeah, because they're parallel lines.
And then you just use cosine law.
Yeah. With the parallel lines.
Okay?
Yep.
Right. The most difficult thing about all of these is setting them up. You guys have all the ability to do the law of sines, law of cosines, right angle trig. You can do all that, but you're all gonna have struggles with setting up your diagrams. The easiest thing to do, or the only thing to do, is draw them out individually to start with. And then work using your equation from that point on. Okay? Alright. Anybody else today?
13.
Mary?
Let's go ahead.
14, so it doesn't, you should do this.
Okay, 14 I like, and you're gonna see it, because it's asking you to do all the components. So basically, you're just setting up a big chart. How many vectors do you have there? How many vectors?
4.
4. So you have to find the components of each vector. So I'll start with the first one, 600 east, 47 north.
When it says like things like west of north, so you go north first and then you go west?
So find the vertical and the horizontal components here. So that's going to be east and north. So just use your right angle trig. 500 meters north, 38 degrees west.
That angle, isn't it?
North. I did put it draw it west, you're right. Next one's this way. North 38 degrees west, is that right?
No.
500 meters. So you're gonna get a west one, you're gonna get a north one. Then you have 300 meters west, 29 degrees south. West. Should move this all down. The last one is south 13 east. And that is 400 meters. So you have all of those So you're gonna have 2 easts and 2 wests, and you're gonna have 2 norths and 2 souths. And then at the very end, draw out your last right triangle.
So these ones you can, because they're kind of going the same direction, the east, north, and west are kind of going the same. So you can actually subtract them,
Yeah, yeah, you can. You have to make one positive and one negative. Just so that you remember that you're, so I would add all the east together and I would subtract all the west. And if it ended up as a negative, then that means I had more west than I did east. Does that make sense?
you would do it.
Okay, well, you have to do it. I don't have a calculator. Give me the east. So coast 47 times 600, what is that?
409.
Pardon me?
409, that's for the 19.
199?
Yeah.
So that's east. Write that in there. 409.199 east. Okay, calculate the west up there. Sine 38 times 500.
307.131.
Dot what?
831.
So that's 307.831 west. Okay, down here, where's the angle on this one? West 29 south. So coast 29 times 300.
262. 386.
That one's west again. And then sine 13 times 400.
89.980.
Okay, so take 409.199, subtract 307.831, subtract 262.386, add 89.98.
Yeah, negative 71.08.
So So because it's negative, what is it, 71.38?
038.
Because it was negative, that means I had more west than I did east. Because I made these guys negative, I subtracted these, right?
Could you not just add the west together and the east and then? the
Sure.
Doesn't matter.
No. Okay. Just as long as you, so when you do that, you'll know which one's bigger. So then you know which way it's gonna be. So yeah, if you like that better, then by all means, that works too. Okay. So now I have the west, then I have to do the same thing with north and south, Mary. And then you draw your final right triangle, and that'll tell you your total displacement. Okay? All right, anybody else today?
Number 13.
Pardon me?
13.
So the only difference between the two is now you have to find your displacements in each of them and draw them out. So you go 100 kilometers an hour for 40 minutes. So how far did you go?
16.
Next one's north 30 degrees east, isn't it?
Yeah. Yeah.
How far did you go there? sorry?
33.33.
And then what's the last one, west?
That was
West.
yeah, that's the immediate,
What is it?
50 kilometers west.
So find your two components there. Once you get your final triangle, then you divide that by your time, and that'll tell you what your average velocity was. But you have to find the individual displacements. Again, that is another test question.
So you use that chart to find the displacements and you just add them up?
Well, you would create a third grade triangle. So you have 66.667 east. You have 50 west. What is this one east? What's half of that?
Half of 66.67.
Not half of 33.33.
16.665.
So that's east. And then you have one north one. So what's the cos of 30 times 33.33? So you have a north, 28.865. You gotta add and subtract those, so 66.67 at 16.665, subtract 50. What is it?
33.332.
So that's gonna be east. I draw north, east, and right there is my displacement. You need that angle, and then divide it by the time and you're done. And you got your average velocity.
What happens if you
The
have
mistake, go ahead.
what happens if you have nothing for y, but you have nothing, everything for x, like 3 or 4 or 5 units?
That's fine. Then you just,
Finding
you're
out
not
now?
gonna see that though.
Okay,
You'll never have just east west. If that's the case, then you just subtract them and you only go in one direction.
okay.
I was gonna say, the mistake that gets made is people don't change to displacement in this question. You have to change to displacement. You find all your components using displacement. Everybody will just take the 100 kilometers an hour and do all the 100 kilometers an hour instead of changing it to displacement. When you're finding average velocity, you need to find your displacement first and then divide it by time to get your average velocity. Okay? All right? No? Anybody else?
Yeah, how did you get to 33.33 kilometers? Is that just basically, like, what did you?
No, I took 100 kilometers an hour
You multiplied it by.
by 1/3 because 20 minutes is out of 60.
Yeah.
Okay? Yeah, I just use the, it's given in the book.
Page 125, question number 29. What does it mean 30 degrees east of north? What does east of north really mean? It sounds a little different than older question.
It means you're going north and you go 30 degrees east of that.
That's west.
That's west. Second time today.
I'm not the only one making silly mistakes, Mr. Young.
You ready? Happens to everybody, Morgan. Even the guy that shouldn't. Okay? So that's what it means. East of north means you go north and then you go east of it.
Okay. Part that might confuse me is north of, east of north. So,
So you're going east of the north direction.
yeah,
So draw your north direction and go east of it.
okay. The part that I worry that I might confuse on the test or in the future is I might think about But then, well, what I'm thinking about is on the north, but then that's heading north, okay, now I see how that works. Is you're heading north still, so
Okay.
that's how that works.
Alright. Okay. You have the rest as a work period. 25 minutes.
Can I go for a minute?
Yep.